Hey guys, good morning. Can you hear me? Hello. Yes, good morning, guys. Can you hear me? Yes. Yes, if anyone unable to hear me, please rejoin. Anyone unable to hear me, rejoin the session. Rejoin the session. Rejoin the session. If anyone unable to hear me, rejoin the session. Yes, if anyone unable to hear me, just rejoin the session. Rejoin the session. Yeah. So let's start session. Yes, let us start session. Yes, last class. Yesterday, all these basics completed previous class. Yes, low level language, high level language completed. Next, interpreter and compiler. This topic also completed. Interpreter and compiler. This topic completed. Java depends on both interpreter as well compiler. So this topic also completed. Yes, there is no concept of exe files in Java. So up to this is completed. Today topic about Java features. See your class online 30 AM. See day 1. JDK 1.0 first version of Java. Sorry, day 2. See, first version of Java released with these features, right? Yes. Now you can understand these features very clearly. Yes, the prerequisite completed, all basics completed. Yes, before going to Java, yes, all that basics cleared. Now you can understand this one. These features now you can understand. Independent of platform. Independent of platform. Independent of platform. See, Java is an independent of platform. Yes, what does it mean? What does it mean? Java is an independent of platform. Java is an independent of platform. Java is an independent of platform. What does it mean here? Yes. For this answer. Yes, here platform means OS. Platform means it's a operating system. Platform means operating system. Operating system. Platform means it's a operating system. Platform means operating system. Platform means operating system. See, at the beginning we discussed beginning classes. Yes, OS is a platform. OS is a platform, on top of it all are running. Okay, OS, it's a platform, on top of it all are running. Okay. Yes, OS, operating system, is a platform. Operating system platform, on top of it all are running. So OS acting like a platform. OS acting like a platform. Okay, so here platform means OS. Platform means operating system. Java is an independent platform. Okay, what does it mean? Okay, yes, for this answer, Java program can run on any operating system. Any operating system. Java program can run on any operating system. Java program. See, Java program can run on any operating system. That is independent of platform. Java is independent of platform. meaning Java program can run on any OS. Here platform means operating system. So Java program can run on any operating system. Okay, fine. Now how Java made us independent of platform. Independent of platform. Yes, immediately question. How Java made us independent of platform? How Java made us independent? Yes, how to answer this question? We should answer this question. Okay. Here, this is important point. How Java made us independent of platform? Yes. Just to answer this question, here, first of all, yes, you must know about exe file and dot class files. What is exe file? What is dot class file? You must have that exe file knowledge and dot class file knowledge. So first of all, about exe file. First of all, about exe file. What is in exe file? About exe file. About exe file. See here some question for you. Yes, what is exactly exe file? What is exe file? What is exe file? What is exe file? Yes, what is exe file? See, exe file is a binary code file. Exe file is a binary code file. Binary code file, and it's a JVM understandable language. It is a JVM understandable language. It's a JVM understandable language. So what is an exe file? What is an exe file? What is an exe file? For this answer, exe file is a binary code file. Exe file is a binary code file, and it's a JVM understandable language. It's a JVM understandable language. Exe file is a binary code file, and it's a sorry. It's a system understand. Sorry, it's a system means processor. It's a processor understandable language. Binary code. It's a processor understandable language. Okay. So what is an exe file? Yes, exe file is a binary code file. Binary code means zeros ones. Binary code means zeros ones. It's a binary code file. Exe file is a binary code file, and it's a system. System is processor. Processor understandable language. Okay, right? So exactly what is exe file? Yes, what does it contain? Some question. One more question here. Exe file. Yes, exe file prepared. Exe file prepared on Windows OS. On Windows OS. Exe file prepared on Windows OS. Windows OS. Exe file prepared on Windows OS. Can I run on Linux OS? Yes. Exe file. Question is here, exe file prepared on Windows OS, can I run on Linux OS? Anyone can you answer this? Your idea? Of course, I'll explain. Just I'm asking your idea. Exe file prepared on Windows OS, can I run on Linux OS? Exe file prepared on Windows OS, can I run on Linux OS? Yes, anyone? Please try to answer it. Of course, I'll explain very clearly. Exe file prepared on Linux, exe file prepared on Windows OS, can I run on Linux OS? The answer is no, we can't. We can't. Yes, reason. What is reason? Yes, exe file prepared on Windows OS, can I run on Linux? No, answer is no, we can't run. We can't run. Reason, exe file is an OS dependent. Is an OS dependent. Exe file is an OS dependent. Yes, immediately question. Why exe file is OS dependent? 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 Okay. So why exe file is OS dependent? Okay. So why exe file is yes platform dependent? Okay. Exe file is platform dependent. Okay. Platform or OS same. Exe file is OS dependent. Why exe file is OS dependent? Yes, for this purpose. Yes, you must have the exe file knowledge. To answer this question, you must have exe file knowledge. So, yes, exe file contains what? Yes, exe file contains what? So, exe file contains what does it contain here? Exe file, what does it contain here? Let us see. Suppose, for example, C program. Yes, C program exe file. C program exe file prepared. C program exe file prepared on Windows OS. C program exe file prepared on Windows OS. C program exe file prepared on Windows OS. Then it contains yes binary codes for C program, binary code for C program, binary code for C program, binary code for C program, plus binary code for C library, binary code for C library, plus binary codes for OS library, binary code for OS library, binary code for C program, binary code for C library, binary code for OS library. See, exe file prepared and Windows OS here. Then it contains binary code for C program plus binary code for C library, binary code for yes, Windows OS library, binary code for Windows OS library, binary code for Windows OS library. Okay. Yes, let me show that practically. C program. See. Yeah, this program previously already we discussed about this program. One second, just a minute, please. Just wait for a minute. Yeah, this is program, for example, here C program. Yes, about this program already we discussed. Yeah, this program, backend of this program, math.cpp, backend of this program. C drive, Turbo C, in folder, math.cpp, math. Let me delete all this. Some existing files, old files deleting. See, this is math.cpp. Okay. Now here I'm compiling Alt C for compile, only compilation, just compiled. See, when compiled and file created, object file created. See, check the properties. Here this is a .obj file, object file. .obj, object file. Yes, what is this object file here? .obj, what is this object file here? Object file. So what is this object file? Yes, this object file contains binary code for C program. So object file contains what? Binary code for C program. Yes, C compiler convert this whole code into binary format and write to this object file. So math.obj, this object file contains binary code for our C program, binary code for C program, binary code for C program. Next, see, this is C library, stdio data and conjure data. It's a C library. It's a C library. That library also contains binary codes. This library also contains binary codes. Binary codes. See, now it's creating exe file. Yes, now run. When you try to run it, first of all, it creates exe file. See that exe file created. Application math application. It's exe file. See properties. Check the properties. .exe extension .exe type of file exe .exe means is exe. So exe file created. How that exe file creating? How that exe file created here? Okay. Yes. What happens here? Compiler takes the binary code for C program plus binary code for C library. So that means binary code math.obj file. It will take the math.obj file. Next, it will take stdio data, this header file binary code here. Next, OS library also. It will take OS library. Yes, C program exe file prepared and Windows OS. C program exe file prepared and Windows OS. Yes, then that C compiler taking binary code for your C program. Okay, binary code for C program is that math.obj file here. Next, plus binary code for binary codes. Binary code for C library. Binary code for C library. So C library binary code plus binary code for Windows OS library. Binary code for Windows OS library. By linking all of this in generating exe file. By linking all of this in generating exe file. Okay. See, at the beginning we discussed about OS. In OS, every program has to link with OS library before going to run here. Every program has to link with OS library before going to run. That program has to link, see, these programs, C program or C++ Java something, these programs linking with OS library, it has to link. So why library here? To communicate with the hardware components. To communicate with hardware components, these programs have to link with OS library. After linking, then communicates with the hardware. Every program has to link with OS library before going to run. Now here, yes, in C language here, at the time of generating exe file itself, that's OS library linking. So here C program, exe file prepared on Windows OS, then it contains binary code for C program, plus binary code for C library, plus binary code for Windows OS library. By linking all of these things, generates exe file. By linking all of these things, generates exe file. That is exe file. Okay. Suppose one more example. Suppose C program exe file prepared on Linux base. C program exe file prepared on Linux base. C program exe file prepared on Linux base. Then it contains binary code for C program, binary code for C library, binary code for Linux OS library. By linking all of this, generates exe file. C program exe file prepared on Linux base. Then binary code for C program, binary code for C library. Now binary code for Linux OS library. Yes, let us see on Linux OS also. Linux OS. Let me start Linux OS. Yes, I'm coming. Just wait. On Linux also calling as exe file. On Linux also same exe file. File name is exe only. Okay, on Linux also file name is exe file, but don't have extension. In Linux, don't have extension for exe file. Okay. Demo login. I'll show that. Now practically I'll show. I'm showing demo. Linux login. Yes. See, in Linux you can see practically. See here in Turbo C, Windows based Turbo C, everything happen backend. Creation of exe file, compilation, creation of exe file, all these things happening in backend here. Backend happening here. Yes, in Linux we have to do everything manually. In Linux, let us see. Practically now can see Linux. Yes, PWD means present working directory. LS, its contents. Okay. Yes, mnraw directory. CD, change of directory. CD mnraw, change to mnraw. Doesn't work in directory mnraw. ls its contents. One second. Remove p star. Remove here. Remove start.o. That object file removed here. ls c. s.c. Gedit. It's a Linux editor, like a Windows notepad. Like a Windows notepad, Linux notepad. It's Linux notepad. Gedit. Gedit means graphical editor. Graphical editor. Now opening that editor. See, this is notepad. Notepad. Here, writing C program. In notepad, we should write C program. A equal 10, B equal 20, C equal to A plus the same program. Addition, subtraction, multiplication. Multiplication, right? Yes, now this program, ls. Test.c, now we should compile it. cc-c test.c. cc means C language compiler. cc means C language compiler. -c means only compile option. cc means C language compiler. -c means yes, only compilation option. Only compilation. Only compilation. Yes, compiling test.c. Compiling test.c. ls. See this. Yes, test.c compiles and generated test.o file. Test.c file compiled, generated test.o. Yes, test.o its object file. This object file gets binary code for C program. Binary code for C program. Binary code for C program. So binary code for this. So this is C program binary code, right? Yes, here also hash include std address header file. Binary code for header file. Okay. So binary code for C program plus binary code for that header file plus binary code for this Linux OS library by linking creating exe file. Now creation of exe file. cc-o. O means object file. O means object file. Creating as exe. Some projects. Yes, exe file name is project test.o. Yes, created ls. That project exe file created. This exe name can be anyone. No issue. Anyone. This result exe. Result exe can be anyone. /project exe file. Yes, running. Yes, addition, subtraction, multiplication. Addition 10 plus 20, 30. Subtraction 10 minus 20 is minus 10. 10 into 20, 200 multiplication. So getting right. That's it here. The project exe file created. Project exe file created. Project exe file created. Right, okay. So what is this exe? That project exe. Let me show that exe file. Project exe file. Project exe file. Yes, it's opening. Yeah, this is exe format. Zeros ones. This is exe format. So this exe for zeros ones. Zeros ones. It's exe file. It's exe file. That exe format. Now this exe file, how this generating here? How this exe generating here? See here. See, like it's generating exe file, right? C compiler taking object file for our program is binary code for our C program plus binary code for std address header file and binary code for Linux OS library by linking all of this in generating that project exe file. Project exe file. See, in Linux there is a command, file command to check the type of the file. There is a file command to check the type of the file. See, test.c. What is that file? Yes, file command to check the type of file. Test.c. What is test.c? Test.c, C source ASCII text. C source ASCII text. It's a C source. C source ASCII text. C source ASCII text, right? C source test.c. C source ASCII text. C source ASCII text, right? C source is a C source. Test.c is a C source file. It's a ASCII text. Now, file command check the project. What is this project here? Project file projects Yes, what is it project here? Yes, project. It's a executable file. Project is a executable file. It's a executable. See that project is a executable file. Now you see this. ld-linux x8664.so.2. See, .so is an extension for the OS library. .so is an extension for OS library. This is Linux OS library. Linux OS library ld-linux. Okay. Yes. So this is Linux OS library. So this Linux OS library linked to this project.exe file. So this project.exe file, executable file, okay, it contains Linux OS library. I think now it's clear. Linux is very clearly prepared. First compilation, then creating exe file, that project.exe file generation here, that project.exe file contains binary code, even that binary format also, yes, clearly showed. Now project.exe file. So this is that OS library linked with project.exe file. That's it. So this is about exe file. So this is about exe file, right? Exe file. Okay. C program exe file prepared on Linux OS. Then it contains binary code for C program, binary code for C library, binary code for Linux OS library. Suppose one more example. One more example. One more example. Yes, C++ program exe file prepared on Windows OS. Then it contains binary code for C++ program. Next, binary code for C++ library. Next, binary code for yes Windows OS library. That is exe file. Okay, did not understand. See what happens here. See, gedit test.c. This is test.c program, right? This program compiling. CC for compiler. CC means C compiler. I means compile option test.c compiler. Yes, generated test.o. This test.o file contains test.o means object file. Object file. This object contains what binary code for our C program. This test.o contains binary code of our C program. Yes, binary code for C program. Means this our C, this part void main and this part, right? This part. The source code converts into binary code generating .o file. That .o file, test.o file contains binary code for C program. Next, apart from this, in C program, there is stdio data header file linked. This header file is also having its own binary code. This header file predefined library that is also having its own binary code. Yes, for this already available file, this is predefined library file. That library file also having binary code. Okay. Now, exe file creating cc-o project. Exe file name is project here. Project exe name. Here test.o. Yes, -o means object file linking. CC-o linking object files. That means what happens here? Now C compiler it takes test.o. So C compiler it takes test.o. So it means binary code for our C program plus binary code for stdio data set file. Okay. Next, binary code for Linux OS library. By linking all of this, it generates project.exe file. Now this project.exe file contains what? Binary code for C program, binary code for C library, stdio data set file, and binary code for Linux OS library. By linking all of this, it generates exe file. That is exe file. So exe file prepared on Linux OS, then it contains binary code for C program, binary code for C library, binary code for Linux OS library. That is complete exe file. So Linux OS library linked to that exe file. C program binary code. Yes. So binary code for C library here. C library. Next, binary code for Linux base by linking all of these generating exe file. Now you can check it exe file. Gedit project exe. Yes, you don't think about Linux. Our topic is about not about Linux base. Our topic is about exe file. Okay. Our topic about exe file. See, project exe file I am opening here. Project exe file. Yes, you don't. Yes, Linux is not our topic. Our topic is about exe file. Just opening that exe file. See this. This exe file format. Zero response. Binary code, right? It's exe file format. Now this exe file contains what? Contents of exe. See, Linux is a file command that check the type of the file here. Suppose test.c. What is test.c? File command checking type of file. Test.c. Yes, what is test.c file here? Test.c. It's a C source ASCII text, right? ASCII text. It's a text file here. C source means it's a C source code. Test.c C language source code program. It's a source code program. It's a source code. C language source code. Okay. So file command is to check the type of the test.c file is a C program source code. It's a ASCII text. It's a text file. Now file commands checking for project file. Project file. Projects. The project file. What is this project? Type of project file is what? Executable. Is it clear this point? Project is an executable file. Okay. Now here this is ld-linux.so.rich. Here this is OS library. .so is an extension for the OS library. So this exe file contains OS library, Linux OS library. I think clear, right? That is exe file. That exe file contains Linux OS library. That is about exe file. Okay. So here, yes, exe file prepared are anyways that links with OS library, linking with OS library, linking with OS library. Okay. So what happens here? Exe file, yes, always links with OS library. Exe file always links with OS library. Links with OS library. OS library. Exe file always links with OS library. Okay. So exe file always links with OS library. Okay, right? See, at the time of generating exe file itself, at the time of generating exe file, OS library, yes, links with OS library, links with exe file. Okay, at the time of generating exe file itself, at the time of generating exe file, OS library links with exe file. Yes, it is called as statically linking. It is called as statically linking. Statically linking. Okay, statically linking. See that OS library statically linking with exe file. So OS library statically. Okay, OS library statically linking. OS library statically linking with exe file. Statically linking with exe file. So OS library statically linking with exe file. Statically means at the time of creation of exe file itself. Okay, at the time of creation of exe file itself. Okay, at the time of creation of exe file itself, linking. Okay, suppose if it is linking at runtime, that is called dynamic linking. Yes, in Java, next topic we'll discuss. What is dynamic linking? We'll discuss next. Dynamic linking we'll discuss next. Dynamic linking we'll discuss next. Okay. Yes, dynamic linking we'll discuss next here. It's Java program we'll discuss. Java, yeah, that OS library dynamic links. Dynamic means runtime. If it is linking at the time of generation of exe file, that is static linking. Suppose if it is linking at runtime, that is called dynamic linking. If it is linking at runtime, that is called as dynamic linking. See, OS library means, see, in previous classes we discussed. Yes, every OS has its own library. There is a library. OS library. That library is a input output function. OS library contains all input output functions to perform IO operations with hardware components. Input output operations with the input device and output device. Library. It's a collection of input output functions. OS library contains all the input output functions to perform IO operations with hardware components. To perform IO operations between application software and hardware components. Library. Library is a collection of functions. Library is a collection of functions. It contains all input output functions. It contains all input output functions to communicate between application software and hardware components. See, every operating system has its own library to communicate between application software and hardware components. Same point. Yeah, that is OS library. Library contains some input output functions. Okay, so C program links with OS library. C program links with OS library. Okay, so what happens here? OS library statically linking with exe file. Okay, next after running exe file. Okay, yes. Suppose for example here, suppose test.exe file. Test.exe file prepared on Windows OS. Then it contains yes Windows OS library. Then it contains Windows OS library. Okay. Support test.exe file prepared on Windows OS. Then it contains Windows OS library. Okay, so test.exe file with Win library, yes, working on different platforms. Platforms are operating system. Working on different platforms. Let us see. Test.exe file with Windows library. Test.exe. For example, test.exe file prepared on Windows OS, then it contains Windows OS library. Test.exe file with Win library working on different operations. Test.exe file with Win library working on different operations. How it's working on different operations here? Okay, see, let us see. Let us take different platforms here. Different platforms, hardware. Yes, your computer hardware. Here there is a hardware. 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 On top of hardware, operating system. On top of hardware, this is operating system. Now Windows OS. Now let us say Windows OS. Windows OS with Win library. Windows OS with Win library. Windows OS with Win library. Hardware on top of it, Windows OS running here. Now on top of it, C program, the test.exe file. On top of it, test.exe file. So on top of it, test.exe file. Okay, test.exe file with Win library, with Windows library, working with different platforms, not with Windows platform. So when you try to run test.exe file, yes, it will try to call to Win library. Okay, it will try to call to Win library. Yes, when you run this test.exe file, yes, it will try to call to Windows library here. It will try to call to Windows library. See, test.exe file running on Windows OS. Test.exe file running on Windows OS. When you try to run it here, it makes a call to Windows OS library. Yes, already available here. Simply calling Windows library. Using that library communicates with the hardware components. Okay, so test.exe file. Okay, it makes equal to Windows OS library. Okay, already here it's available. Just calling Windows library. Yes, since test.exe file linked with Windows OS library, this test.exe file linked test.exe file linked with Windows OS library. Since linked with Windows OS library, it will try to call to Windows OS library. Windows OS library, yes, available. So this program executes successfully. So using that Windows library communicates with the hardware component. So program executing successfully. Program executing successfully. So program executing successfully. Right? Okay. Yes. Let us take another platform. Let us take another platform. Let us take another platform. Another platform. Another platform. See another platform. Now Linux base. Linux base with Linux library. Linux base with Linux library. Linux base with Linux library. Yes. Linux base with Linux library. Yes, how it's working. Same test.exe file. If you try to run a Linux base, what happens here? See this exe file already linked. Exe file, yes, with Windows library already linked. That link is fixed. Statical linking. Statically means fixed. That link is fixed. Never changes. That link never changes. Now the test.exe file contains what? Windows OS library. Same test.exe file. If you try to run on Linux base, what happens? Same this test.exe file take onto Linux base. If you're running on Linux base, what happens? If you're running on Linux base, then what happens? Okay, then what happens here? One second. Yes, same test.exe file running on Linux base. What happens? Now this test.exe file, it will try to call to Windows OS because already this is linked with Windows OS library. Instead of test.exe, Windows OS library is there. So it will try to call to Windows OS library, but here is not available. It's a different library available. Okay, test.exe file linked with Windows OS library. When you try to run it here, it will call Windows library, but here different library. Linux library is available. So Windows library different, Linux library different. No matching. Simply fails. That exe file fails. Cannot run here. Exe file fails. Let us take another operating system. Okay, test.exe file. Placing on macOS with Mac library, macOS with Mac library, macOS with Mac library. Okay, now same test.exe file. If you're running on Windows OS or Linux OS, same test.exe file. When you're running on Mac OS, same thing happens. It takes a call to Windows library because it's already linked with Windows OS library. Since exe file linked with Windows OS library, it will try to call to Windows library, but here different library available. So simply it fails. Simply it fails. Yes, since exe file statically linking with OS library, it's a OS dependent. Okay. Yes, test.exe prepared on Windows OS, then running on only Windows OS. Suppose exe prepared on Linux OS, running on only Linux OS. So that's the reason exe file is a OS dependent here. Exe file is a OS dependent. Okay. See, since exe file statically means at the time of creation of exe file itself, not runtime, at the time of generating exe file itself. Since exe file statically, yes, statically linked with OS library. Since exe file statically linked with OS library, yes, it is a OS dependent, OS dependent. Okay, yes. Now here question, what is question? Let us back to question here. Yes. See about exe file. What is an exe file? Yes, exe file is a binary code. The binary code showed already. It's a binary code file. It's a processor understandable language. Processor understand 0s1s format. Okay. See, exe file prepared on Linux Windows OS. Can I run on Linux OS? No. Reason, exe file is OS dependent. So why exe file is OS dependent? Simple answer. It contains OS library. Simple answer. It contains OS library. That's it. Very simple answer. It contains OS library. Okay. Yes. It contains OS library. It contains OS library. Simple answer. It contains OS library. Okay. Yes, it contains OS library. It contains OS library. Since exe file statically linked with OS library, yes, it's a OS dependent. That's it. It's a OS dependent. So this is about exe file. Now let us come to dot class file. Java dot class file. Now let us come to Java. Java dot class file. Java dot class file. Yes, about Java dot class file. About Java dot class file. Java dot class file. So what is dot class file? What is dot class file? What is dot class file? So what is dot class file? What is dot class file? What is dot class file? Yes, dot class file. See, dot class file is a bytecode file. Dot class file is a bytecode file. Dot class file is a bytecode file, and it is a JVM understandable language. JVM means Java Virtual Machine. Java Virtual Machine. JVM understandable language. JVM understandable language. It's a JVM understandable language. Dot class file. Dot class file is a bytecode file. Dot class file is a bytecode file and it's a JVM understandable language. Dot class file is a bytecode file and it's a JVM understandable language. JVM is Java Virtual Machine. Yes, about JVM next class we'll discuss. Next class we'll be discussing about JVM clearly. Okay. It's a dot class. Dot class is a bytecode file. It's a JVM understandable language. So exactly what is dot class file? Dot class file contains what? See, dot class file like exe file. So dot class file contains what? So what does it contain? Dot class file. Yes, what does it contain? Dot class file. What does it contain? Let us see. What does it contain here? Same example here also. We'll take same example. So for this example, let us take this example like C programming, Java. For example, C program in place of C, Java. In place of C, Java. Java program exe file in place of this dot class file. Java program dot class file prepared on Windows OS. Okay. Java program dot class file prepared on Windows OS. Java program dot class file prepared in Windows OS, then it contains bytecode for Java, not binary code, it's a bytecode. Bytecode for Java program. Bytecode for Java program. Bytecode for Java program. Next, bytecode for Java library. Bytecode for Java library. Bytecode for Java library. Bytecode for Java library. Next, binary code for OS library. No, don't have this part. Only that's it. This is dot class file. See, Java program dot class file prepared in Windows OS, then it contains bytecode for Java program, bytecode for Java library. See, Java library also developed in Java. Java library also developed in Java. Java library also developed in Java. So Java library also developed in Java. Okay, see, C language library developed in C language. Python library developed in Python. C++ library developed in C++. Java library developed in Java. Okay, so Java library also developed in Java, means it's Java code. This is also Java code. Okay, so bytecode for your Java program, bytecode for Java library, bytecode for Java program, bytecode for Java library. That means it's a pure Java program. Yes, it's a dot class file. See, dot class file. Dot class file is a pure pure Java program, pure Java codes in byte format, in byte format. Yes, in bytecode format, in bytecode format, bytecode format. Okay, so dot class file is a pure Java code in bytecode format, in bytecode format, in bytecode format, bytecode format, bytecode format. Okay, so dot class file is a pure Java code in bytecode format, in bytecode format. Okay, yes. So dot class file, see dot class file, dot class file, dot class file. Yes, don't have any voice library. Dot class file don't have any voice library, no voice library, pure Java code. Yes, don't have any voice library. So don't have any voice dot class file. Dot class file don't have dot class file. Dot class file don't have any voice library. Yes, it's a pure dot class file is a pure Java code. Dot class file is a pure Java code in byte format. Dot class file is a pure Java code in byte format, byte format. A dot class file don't have any voice library. Yes, it is free from voice library. It is free. It is free from voice library. It's free from voice library. It's free from voice library. It is free from voice library. It's free from voice library. That is about dot class file. Dot class just is a pure Java code. It's a pure Java code. Don't have any voice library. It's a free from voice library. It's a free from voice library. Now let us take some tested dot class file. Tested dot class file. Tested dot class file prepared on any ways, but don't have any ways. Yes, but don't have any voice library. No voice library. Tested dot class file prepared are anyways, maybe Windows ways or Linux ways, Unix ways, anyways, but don't have any voice library. Okay. Now tested dot class, how is working on different platforms? Tested dot class file, yes, working on different platforms, working on different platforms, working on different platforms. So how it's working on different platforms? Tested dot class are working on different platforms. Let us take different platforms like exe file. Here also, let me explain about dot class file and different platforms here. Okay, hardware. On top of hardware, this is Windows OS. On top of hardware, Windows OS. On top of Windows OS, here the dot class file running here. Dot class file. Just dot class file running. Now, so this tested.exe file, sorry, test.dot class, this dot class file placed can in this ways. When you try to run it, yes, will it work or not directly here? It will work? No. This dot class file you can't run directly here. You can't run because here dot class file free from voice library. Dot class file don't have any voice library. Don't have any voice library. See, in voice concepts we have discussed it. Every program has to link with voice library before going to run here. Every program has to link with voice library. So linking with voice library, it has to link. Yes, even the Java program also has to link the tested dot class file. This tested dot class file also has to link with voice library. Otherwise cannot run, but not linked. Tested dot class file is not linked. It's not linked. It's a free from voice library. Yes, it is free from voice library. Don't have any voice library. Then how it cannot? No, it cannot run. It cannot run. Dot class file cannot run here. To run the dot class file, it has to link first of all. To run the tested dot class file, it has to link with voice library. Okay, so it has to link. Then who will link it here? For this purpose, between tested dot class file and voice, one more layer come to picture. Yes, what is this layer? Anyone can you guess it? What is this layer? Between tested dot class file, Windows OS, one more layer comes. That will link the tested dot class file with Windows OS library. Who will link it here? Someone has to link. This tested dot class file has to link with OS library. Someone has to link. Who will link it here? Who will link it here? For this JVM. For this JVM, of course. Yes, Avinash Swain, you are correct. Interpreter, okay, I'll agree with interpreter. Interpreter is a part of JVM. Inside the JVM, there is interpreter. That interpreter will link. Okay. Yes, in JVM, I'll explain clearly. Actually, that's a part by the interpreter. Yes, it's by the interpreter. Yes, where is interpreter inside the JVM? That interpreter is inside the JVM. Inside the JVM. Okay. Now JVM taking test.class file. JVM taking test.class file links with Windows OS library. Links with Windows OS library. Once linked with Windows OS library, then communicates with hardware components. That's it here. Okay, so JVM taking your test.class file links with OS library. So once linked with OS library, yes, once linked with OS library, then program execution starts. So JVM takes care of linking. Now let us take another platform. Same test.class file on another platform. Suppose, yes, Linux platform. Let us take Linux OS with Linux library. Linux OS with Linux library. Now what happens? Same test.class file. See test.class when test.class for running on Windows OS. That Windows JVM taking test.class for links with Windows OS library. Suppose same test.class file if you're running on Linux OS here, that Linux JVM. 1 second. Yes, that Linux JVM taking test.class file links to Linux OS library. Okay, so Linux JVM taking test.class file links to Linux OS library. So Linux JVM taking test.class for links to Linux library. Once linked with Linux library, then executes generating output here. Yes, one more OS, Mac OS. If it is Mac OS and Mac OS also Mac JVM, Mac OS, Mac library. Now here also Mac JVM, yes, Mac JVM taking test.class for links to Mac library. Once linked with Mac's library, then communicates with hardware components. Just wait. Kalyan Chakravarti, wait. I'm coming to your doubt only. Next topic, your doubt only. Okay. Your doubt, just wait. Okay. Now what is happening here? Yes, if dot class file running on Windows OS, JVM links dot class file with Windows OS library. Suppose same dot class file if you're running on Linux OS, Linux JVM links dot class file with Linux OS library. Same dot class file if it is running on Mac OS links to Mac library. That means for every time of changing OS that link changes. So for every time of changing OS, changing OS link changes. Every time of changing OS link changes. Every time of changing OS link changes. Yes, it is called as dynamic linking. It is called as depends on ways that link changes. It is called as dynamic linking. Okay, so every time of changing ways that link changes here. Okay, if we're running on Windows OS links to Windows OS library. Yes, running a Linux file links to Linux. That link changes. Okay, that link changes. Chandrasekhar, wait. Your doubt also coming in next couple of minutes only. Next couple of minutes. Okay. Yes. So every time of changing ways, link changes. Yes, it is called dynamic linking. So what happens here? Java program dynamically linking with OS library. So depends on ways that link changes. Since dynamic linking, it's independent of platform. Yes. Since Java dot class file dynamically linking with OS library. So OS library. So since Java dot class file dynamically linking with OS library, yes, it is an independent of platform, independent of platform. I think this point is clear, right? Yes, since Java dot class for dynamic linking is runtime that link changes. So here runtime. If it is running on Windows OS, links to Windows OS. If it is running on Linux OS, linking to Linux OS here. If it is running on Mac OS, links to Mac library here. So it depends on which that link changes. So that is called dynamical linking. At runtime, link changes. What happens in case of exe file? See, at the time of creating exe file itself, OS library linking with exe file, it's a statical link, it's a fixed. That link is fixed. That OS library linking with OS library, statically linking with exe file, there is a fixed here. Statically means fixed. That link never changes. Since statical linking, it's a OS dependent exe file. So exe file statical linking. Since exe file statical linking linked with OS library, it's OS dependent. Yes, when come to Java here, Java. Since Java dot class for dynamically linking with OS library, yes, it's an independent of platform. I hope this point is clear. Okay. Yes, how Java made us independent of platform? Reason, dynamical linking. See, any program statically linking with OS library. Yes, it's a platform dependent. Yes, platform dependent. Okay. See, any program dynamically linking. Okay. Yes, any program dynamically linking with OS library. Yes, that is platform independent. That's platform independent. Any program dynamically linking with OS library, that is platform independent. Statical linking, it's a platform dependent. Dynamical linking, platform dependent. That's it here. Statically and dynamically, platform dependent, independent, like this. That's it here. Now here question, here's some doubt here. Yes, your doubts. Now your doubts. Same topic I'll be explaining now. Yes, here chance of getting this doubt here. Yes, Windows JVM linking test dot class file with Windows OS. Linux JVM linking test dot class file with Linux OS. Mac JVM linking test dot class file with Mac OS. Then JVM, is it part of OS? No. JVM is not a part of operating system. JVM is not a part of operating system. Yes, it is from JDK software. It is from JDK Java software. It is from JDK software. Okay. Yes, JVM is not a part of OS. Okay, JVM is not a part of OS. It is from JDK software. Yes. How can you get JVM here? To get JVM, yes, we need to install. Yes, we need to install JDK software on OS. That's it. Once Java install, getting JVM automatically. JVM is a part of JDK software. It is from the JDK software. Yet to get a JVM, we need to install JDK software on the system. JDK software, you have to install it. That's it here. Okay. Yes, sir. So JVM is not a part of OS. Okay, it is from JDK software. To get JVM, we need to install JDK software. Okay. Next, one more point here. See, Java dot class file. Yes, is an dot class file is an independent platform. Dot class file is an independent of platform. As independent of OS. But Java dot class file is an independent of OS. But JVM is an OS dependent. JVM is an OS dependent. So why JVM is OS dependent? Why JVM OS dependent? Why JVM OS dependent? OS dependent. Why JVM OS dependent? Dependent. Reason JVM developed. JVM developed in C++. JVM developed in C++. JVM developed in C++. Okay, so JVM is a C++ exe file. Yes, if it is C++, definitely exe file. C language C++, exe files concept here. Everything is exe file. If it is developed in C++, definitely it's exe file. JVM is a C++ exe file. That's the reason OS dependent. So JVM is OS dependent. JVM is exe file. See, Sunsoft has developed different JVMs for different operations. Different operating systems here. So Sunsoft has developed different JVMs for different operating systems. Sunsoft has developed different JVMs for different operating systems. Okay, JVM for Windows OS, JVM for Linux OS, JVM for Mac OS, JVM for Solaris OS. For different operations, different JVMs developed here. So Windows JVM is having knowledge of Windows OS, then it can link test.class file with Windows OS library. See, Linux JVM is having knowledge of Linux OS library, so it can link test.class file with Linux OS library. Next, Mac OS JVM is having knowledge of Mac library, then it links with Mac library. That's here. Okay, so here Java.class file is independent of platform, but JVM is OS dependent. Yes, why JVM OS dependent? JVM developed in C++. It is C++ exe file. See, Sunsoft has developed different JVMs for different operations. Okay. Yes. Now, from where getting JVM? JDK, right? JDK, right? Suppose I want Windows OS on Windows OS. JDK on Windows OS. The JDK should contain JVM for Windows OS. Suppose JDK installing a Linux OS. The JDK software should have the Linux JVM. Suppose JDK software for Unix. The JDK must have Unix JVM. Suppose JDK installing for Mac OS, the JDK must have Mac JVM. That means here JVM is OS dependent. Since JVM is OS dependent, JDK also OS dependent here. Yes, since JVM is a OS dependent. JVM is a OS dependent. Since JVM is OS dependent, JDK also OS dependent. JDK also OS dependent. Okay, so same JDK cannot be installed on different operations. See, suppose for example here, see it's a Windows JDK, right? This is Windows JDK. This JDK cannot install with other operations, only Windows OS. This JDK can't install with Linux or other platforms, cannot. So Sunsoft, they are providing different JDKs for different operations. Okay. Yes, let us see that. Yes, JDK download, JDK 8 downloads. Yes, go to here, Oracle Corporation. Now Java with Oracle Corporation. See, these are all the downloads, JDK downloads. See, these all are JDK for Linux OS. JDK for Linux OS. This is JDK for Mac OS. Next, JDK for Solaris OS. JDK for Windows OS. There are different JDKs here. See, for Windows OS, we should download this one here. Okay, you guys don't download. Yes, I have provided already. In Drive, it's available already. In Drive, already available. Okay, let me go to Drive. Yes, the Drive already shared to many students. Yes, already Drive access given to many students. Yes, this is Drive here. Yes, you guys don't download any JDK or Eclipse. Yes, it's available in our Drive here. It's available in Drive. You take from the Drive. Suppose if you downloading, there's a version compatibility problem. JDK and Eclipse version problem, version compatibility. Version may not be matching. Okay, that matched versions I have downloaded and same thing providing you. So take from the you take from the Drive. The drive access already given to almost all students, almost all members in our batch. Yeah, this is about independent platform. Okay, tomorrow topic Java installation. How to install Java, how to install Eclipse. Tomorrow topic. Tomorrow topic going for installations. So this is your drive. No, Avinash already given drive access for you. You are the first guy to give the drive access in your batch. Yes, how to check your drive, I'll tell you. This is MNRA code is a drive. In drive, all the software is available. I have given access like this. Share sooner with a. Okay, let me check with online team. Here they shared only some email shared that I have shared here. So let me check your sooner with I will check it. I'll check with the online team sooner with and yeah, I see. Babina Spain. A B. Okay, let me check it. Yeah, here it's shared like this mnraf nrit2 at gmail.com. Send shared like this. Shared like this. Okay. Sveina. Saying Spagar. Yeah, I'll share it. I'll share it. Yes. Share like this. Right click. Yes, here share like this. mnraf. Yes, here like this shade here. So this is a material drive. All the softwares and material drive here. Next, another drive is recordings. Recordings. One second. Recordings drive. Another drive is for the recordings. Rituja not got access. No, you should get access compulsory Rituja. Yes, one second drive. This is drive. See 10:30 am. Yes, here the recordings. 4 record today. 5th recording will be uploading. share okay. Yes, shared. Now, yes, share to that email, right? Now, how I can access that? Yes, first you log in. Log into your Gmail ID. Yes, this Gmail ID shared. To this Gmail ID shared. Yes, now first log into your Gmail ID. First of all, you log into Gmail ID. After logging into Gmail ID, go to Google Drive, Google Apps. Here there are some Google Apps in this. There is a Drive option. Google Apps Drive option. Drive option. Open Drive. Yes, do like this. Do like this. You can see. Yes, Drive. After login, go to in Google Apps. There is a Drive option. Open Drive. Just open Drive. After opening Drive, here this is shared with me. Open Drive. Go to Drive. Shared with me. Go to Drive. Shared with me. Here you can see Emendra course hours 10:30 am September. This is all recordings. Right click and view, review, open with, yes, it will work. Video player for Google Drive. You can watch from here. You can watch here. Okay. So these are recordings. Recordings. Next software. Just shared with me software. See Emendra course Java. Here this is. Open it. Open it. Open it. Yes. Here right. Now from its right click JDK download. Here download option. Okay, yes, your class document, right click download. That's it here. Okay, see here, go to drive. Yes, go to drive, shade with me. Go to drive, shade with me. Go to drive, shade with me. In shade with me, you can see Emendra course hour 10:30 am. Emendra course hour. These two folders you can see. These two folders you can see. Yes, yeah, I will talk to online team. Some emails may be mismatching. Just I will talk to online team here. Yes, I'll share with you now. Okay, 100% within 10 minutes you'll get the access. Everyone will get the access. Some access missing, someone get the access. This is next. One more thing. Only paid members giving access. Only for fees paid members giving access. That is one more point here. Just remember that point here. Only for paid students giving access. Okay. Yes. For others, yes. Yeah. Let me talk to online team. Let me talk to online team. I'll tell you. Okay. Yes. Okay. Yes. So this is about independent platform concept. I hope it's clear all this. Okay. Yes. Next topic about installations. Tomorrow we'll go for installations. So with this all the basics completed, introductions completed. Yes. Tomorrow we are going for installations. Okay. Yes. By today evening or tomorrow morning class, download all the softwares and ready with your session. Okay. Yes, I'll check. I'll check with online team to give the access once again. I'll check with online team. Yes, I'll give the access. Okay. Yes. By tomorrow morning, be ready with all the softwares. We'll going for installation. JDK software and Eclipse installation, writing first program tomorrow. That's it. Yeah, that's all for today. That's all. That's all. Yeah, thank you guys. Thank you guys. See you tomorrow. See you tomorrow.